we got everybody now, we can start. So welcome to the kernelci.org session. This is what's next, so we're gonna kind of focus on where we're headed and you know, the new features that we want to add. So I'm Tyler Baker, I'm the Director of Engineering for the Automation and CI team at Linaro.
I'm Milo Casagrande, I work on kernel CI.
My name is Kevin Hillman, and I work on kernel CI as well, mostly focused on the kernel development parts of it.
So the way we're going to run this presentation, we're going to go through these slides, but we want to focus mainly on discussion. So at any point during this, just go ahead and throw your hand up, and Cohen will come around with the microphone, and we'll go ahead and answer your question. Let's get started. Okay, so what are we going to talk about in this presentation? We're going to just do a quick overview and a review of kind of where we're at. Then we're going to talk about what's next, and then we want to really start focusing on testing, because right now, currently, we're only showing the boot test results that we're generating, and the next step is actually to run tests like LTP and K-self-test and things like that. So what are we doing today? We've had about 500,000 builds under our belt. We have over 1 million boot tests and around 6,000 test cases executed, and we're counting. So these numbers are approximate. We're over these values now, but that's kind of, you know, the status at this point. So what's next? So these are kind of our thoughts, but we want to solicit it to a wider group to get your feedback. So test visualization. Right now we have build visualization where we can track warnings and errors. We have a comparison view where you can compare 2 different builds or 2 different boot def config builds. Yeah, exactly. And then, yeah, so we have the different diff views, then we have full text certs, and then the move to the cloud. So right now we're kind of just running everything on Metal, but we want to move to AWS and more of a cloud type, more scalable infrastructure in the future. Is there anything here that you guys want to see that's not on this list? This list is comprehensive then.
As you mentioned at the beginning, more like driver type of functional basic checks.
Well, if you want to write some driver tests, absolutely. But typically, I mean,
they're already there.
What's that?
They are already there. LTP, DDT.
Yeah, that's right. Okay, so I mean, we could do that, I suppose. I think we're going to focus on community test suites, so like LTP, a little higher level, and then we'll get to the driver tests. But K-self-test is, I think, the first thing we want to tackle. The issue with K-self-test previously, I think there's been some really good work around it lately, is that it breaks a lot. So we've recently enabled it to build for ARM and ARM64, whereas it only used to build for x86. But we need to actually put the pieces in place so that as we create the build system, that will build K-self-test every time we build multi-v7 def config or ARM64 def config, that we have a way of reporting when the K-self-test builds that fail, right? And so we can go to the K-self-test mailing list and say, hey, this patch broke, build for ARM64, we need to get this fixed. Because what we're going to run into as we're like developing on Linux Next is that the tests are going to break, they're not going to build anymore, and so then we're not going to run the tests. And if we let that happen for too long, then all the work that we've done, you know, up to that point kind of goes away. So that's kind of our first focus, but I think LTP, DDT would be something that we'd probably take on after we have that under our belt. I mean, at least LTP and at least K-self-test. So that's actually a really interesting one. That's something I've kind of started already, but we're going to use QEMU as a platform, because you can just grab a vExpress kernel, build it, and throw it at QEMU with, you know, tip Android and see if it boots with software rendering. So that's something that really maybe we could do with, I don't think is there a mainline platform that we can actually boot the latest version of Android with that's fully supported upstream?
I do it on QEMU. So.
Okay, so that's what you'd prefer to see? Yeah.
But even there, we're not fully validating that actually hits a real user or hits real graphical. We are actually just going through the ADT logs or ADB logs and actually, you know, detecting kind of in a hacky way that it actually made it to the full graphics.
There's a property when Android boots to UI, it just set boot completed equal to 1. So if you just check for that property, it's good enough.
Yeah. That'd be even easier than what we're doing now.
Yeah, because we probably run headless without graphics, so that would be perfect. And so I guess would you want us to build tip AOSP master with upstream kernel, or would there be something, do you want us to do the latest stable?
I think latest stable would do.
Yeah, well, that's what I'm getting at, right? Go ahead.
Stable would do.
So stable with tip kernel, and making sure that always works. That would be sufficient?
Yeah.
Okay. We can write that.
Somebody taking notes.
No, we should though. Okay, we should.
Tyler, did you already talk about scheduling tests or not yet?
No, I mean, we need to get the visualization there
Okay.
before we do it. So that's a good point though. So Milos brought up
Yeah, so-
scheduling tests, because
So yeah, I started doing that for the builds that are already there. So like for some Llvm Blacks build, because we have this hardware in the lab.
Yeah.
But we can do the same for Android. Very same thing. So like filter the builds that the builder does, just pull them and schedule to the lab, and like kernel CI doesn't have to be involved at all, because I'm running the scheduler independently of the kernel CI stuff. I'm just pulling the builds that are available.
yeah. So I think the issue we have with our testing story right now is that we're doing so many boot tests that it's tying the hardware up, and we don't have a lot of redundancy in the hardware. So to run something that, like Hackbench, we have Hackbench, Llvm Bench, we have this all integrated, we can run it at any time. And the way we have it done is we created basically a testing Ramdis that has very minimal support for like Python and things like that, all the shared libraries we need for testing. Why that's advantageous is because that is the lowest common denominator. We don't have to worry about driver support upstream. If it can boot a Ramdis, we can run the tests on it. Now, ideally, we'd like to expand beyond that, but right now, what that enables us to do is actually run Hackbench on every single platform that we have in kernel CI, where kind of previously, some of the other ways we've done testing in the past, we had to have some sort of storage driver so that we could have a real root file system to do the tests, and kind of a bigger user space. So that strategy is kind of the way we're headed, because it's just easier, because we can, as soon as we add a platform that maybe all it has is UART and can boot a RAM disk, we can run tests on it. And so that's kind of what we wanted to chase after. The problem is the tests take, especially Hackbench, where it's kind of performance-based, it can take a long time on a certain platform and a very little amount of time on other platforms. So what it ends up doing is tying up the hardware for various amounts of time, and as the boot tests are coming in, we want to get those through quickly. So we're kind of still figuring out how we want to do that, and how we schedule the tests in an efficient way, because we don't have redundancy in the hardware, right? We might have one board, that's it, in the entire 10 labs that we have running kernel CI. So it becomes a little bit of a problem. I think initially what we're thinking is, where we do have hardware redundancy, we dedicate those devices for just running tests and get those results going, get the test visualization so we can look at them, and then if people want a broader approach, then we just need to figure out how to get more hardware for the project.
We also only do that testing on a very small subset of the trees, like maybe just RC candidates, or maybe just stable releases or something like that. We got to severely limit it, at least until there's a lot more redundant hardware.
As we talked before the connect, it's like it's supposed to be like that. It's actually supposed to be at this time. So along with the test visualization, what I did was a simple scheduler that was basically independent of the builds. So how do we want to go forward with that?
Well, I think that's the beauty of kernel CI, right? I mean, people can use the API and build whatever logic they want around there. So I think that's fine with us. If we could use the scheduler, whatever you figure out to schedule our tests, I mean.
Yeah, so that's the question, how to use this scheduler. So basically, what to run the tests on every tree? Like
No.
Only
So I
the
think
selected
what
ones and so
getting
on.
at is we would have like mainline RC candidates, right? And so you'd use the API to say what new builds are there. If there's a new RC candidate, that we schedule a test.
But then this needs to be included in the APIs that you can query with.
You can,
Right.
that's there in the API today. You can get that. You just have to have some logic on the back end to filter out the RC candidates, right? Whether that's a regular expression. Because you're going to get basically a big list of all the builds that are there, and you just have to pick the RCs out. And then you'll have to probably cross-check. So if you find RCs, you need to make another API call to see if you actually have test results for that. If you do, then you don't need to run the test again. If you don't, then you need to schedule the tests.
Yeah.
Does that make sense?
Well, that's what I'm doing at the moment locally.
Yeah,
So, and only testing with the devices that booted, actually.
yeah. So I think that would be a similar approach, and we can probably just reuse your scheduler to schedule a test, and then we just constrain the hardware that we run on to the hardware that we have redundancy, so that it doesn't affect the boot results.
So probably worth to get a hardware query API, right?
Yeah, I suppose so.
How many boards there is, how many boards there is.
The problem is it's best
idle.
effort, right? These labs can come and go, right? And so the hardware, at a certain point in time isn't going to be there, and kernel CI isn't going to go talk to the labs, right? It's a push method, right? It doesn't
No. It's what I'm saying is like for your own lab, right? Because I'm not scheduling the tests on any lab. I'm scheduling in Cambridge lab only,
Right.
because this is where I have right access. I'm not testing on Kevin's boards, right?
Yeah, but Llava's got an API then to tell you how many online boards there are.
No,
Yeah, it sure does.
no.
Go ahead and look at my scripts. I've got it written. I actually before I send a job to the server, I actually make sure there's enough devices, because we schedule multi-node devices to boot KVM. So I need to make sure that I've got a certain amount of devices. And so it'll actually validate it before it submits the JSON. So the API is there to get the count of devices.
It's probably like a hidden gem.
Any other questions? Okay, so we're going to take a quick, I think we kind of started covering most of this is more hardware, more labs. That's the only way we're going to scale this testing up. Another thing that we discussed is performance numbers. We're not doing any benchmarks, because then somebody can get a hold of that data and make comparisons, which may or may not be fair, and we don't want to get into that business. So specifically, like Fronix could see us publishing benchmark numbers, comparing different platforms to x86, and whether that's good or not is something we probably don't want to go, a road we don't want to go down. So it's going to just be functional tests that we will publish results on. Any questions on that? I know everybody wants to see performance numbers, but it's kind of a slippery slope when you start publishing those numbers publicly.
How many performance benchmarks are running now? And I'm work for Linaro, so can I see the performance data?
So I've kind of, Mark and I have been talking about that. So I can run Hackbench, and I can run LMBench and send a private email to you. I guess you just have to let me know what cadence you'd want that to do. Is that every time the LSK tree changes, we could potentially do something like that?
I'll move it to Friday, so we can then discuss the LSK case, which I wanted to make an example for the scheduler and test visualization.
Okay. Does that answer your question? So basically, we're going to discuss this on Friday further about how we provide you those results. Okay. So we need help. We all have day jobs. Milo's the only one that really works full time on this, so we have one engineer on this project. The labs are kind of just nice people in the community wanting to set up labs that have hardware, and it's actually been really successful. I think we're at 10 labs now. Yeah, so these are people with labs in their house. These are companies that do like consulting work for embedded Linux projects that are setting up the hardware that they're working with upstream. So we're starting to build a good community around this, and it's really exciting to see. It's funny, a lot of people are really interested in just the automation part of it and getting the hardware automated and the boots working. So that's been great. Where we really need help is confirming issues. So we're able to run bisections more or less, completely automated. So we can bisect the patches, but it takes a lot of time to go and make sure that patch is actually causing the problem, understand the issue, report it upstream, and then have that argument when somebody comes back saying, well, no, I think my patch is fine. It eats up a lot of time. So that's what we're really in need of, is people to help us kind of be janitors of the kernel community and say, no, well, this actually is a regression because we have proof that it was working previously and now it's broken and your patch is causing it. And the other issues that we have is sometimes maintainers won't apply a fix to their tree that's in Linux Next. So this happened recently with the NVIDIA Jetson TK1, where there was a pretty nasty bug where it was just causing the console to spew a bunch of messages, and all the automation couldn't deal with the overflow of the serial port. So we got a quick fix applied from the person that wrote the patch, but the maintainer wouldn't apply it to his tree. I think his tree wasn't in Linux Next, and that was the issue. So we had broken that board for, I think it's almost 2 months now. And so we basically need pressure on the mailing list to not let people be able to do this. When there's a fix, it needs to get into Linux Next. Otherwise, what we've found is this actually happened after the holiday break. Early January, we came back, there was 324 regressions in Linux Next. From a clean pass in December, like December 20th, we had 600 boots, perfect, no regressions. Came back after holiday break, 324. And what you find is you start peeling back layers. So you find the first one, right? You revert that. Well, now there's a different boot issue on the same platform. Well, you revert that one, and you can start to go down. So the time it takes to get a fix in Linux Next actually matters, because it can be masking multiple other issues, which then creates more work. I mean, it just kind of builds up. So, that's where we really need help is kind of, community pressure when these issues are found and to get the fixes applied. Now, that's typically not a problem. That's super common where we have to kind of bulldog maintainers into getting those patches applied, but it does happen. And so, any help you guys can provide it would be appreciated. And of course, spreading the word, letting people know. I think one of the really great benefits of kernel CI is that we have a way for somebody to have a board and want to say, I want to boot an upstream kernel. But maybe they were working with a vendor kernel that's using UImage format and different load addresses. So somebody has to kind of play around with their board for a little bit to figure out how to get the upstream kernel booting. And essentially what kernel CI also provides is how we configured board to boot. So it's kind of a community reference saying this is how we're booting upstream kernels on these boards, and this has happened a few times. A Parallella, which is a Xilinx processor development board, we had a couple people on GitHub saying, oh, we'd like to really use a mainline kernel, but we can't figure out how to boot it. And so I was able to point them at kernel CI saying, here's all of the commands that we're using, the U-boot version, exactly where we're loading everything. It's a reference for you to do this, and they were able to get their boards booting mainline kernels, and we're really happy about that. So, that's another advantage of this, is it allows people to have those instructions to get their boards booted with upstream kernels. Any questions? That's it.
The other area that would really help too is if you're particularly care about one subsystem or one area, and you have really good ideas for us how to quickly catch regressions without. A lot of times there are things in the kernel where there's specific error messages that come up that people outside of that subsystem don't necessarily know how to interpret. But as the maintainer or developer in that area, this is almost always indicating a certain type of failure. Those are the kind of things we'd like to see too, because we can put in our little boot log parsers, we can check for those kind of things relatively easy and flag those things as part of the boot test. And so just little kind of tips and tricks that are subsystem specific, or if there are certain types of regressions that you particularly care about and they're easy to scan if you know what you're looking for, that's the kind of stuff that would be really helpful too.
Yeah, so if you want another thing to add on to that, if you want your tree monitored, if you're a maintainer or you're doing a lot of upstream development, if you send us an email at info@kernelci.org, we can sort that out for you and monitor your tree. What that'll give you is, it'll give you a build report of all of the different def configs that we build. So we build all the upstream ones, plus we have a few different combinations where we add config fragments to them. And so you'll get a build report, and then eventually when the boot's complete, you also get a boot report. So if you're ever worried if you've made changes to your tree that are gonna break other boards, you can kind of find that out before you ever, your patches ever hit Linux Next or mainline. So it kind of gives you a little bit of security there. Any other questions?
Work in progress. One other work in progress item. So the company I work for, consulting company Bay Libra, we're working on kind of power measurement type things. So we're working on trying to catch power regressions in mainline. And so if you have ideas or boards that are particularly well suited for measuring power, which a lot of embedded platforms are not very easy to measure power on, or at least in a detailed level that would be helpful, and you're interested in that type of thing, talk to me as well, because we're working on adding that feature to kernel CI as well. So along with boot type logs, you can see power information and power regressions and that type of thing. So that's another kind of work in progress that's happening right now.
would just overall power information for the DC in be useful as well?
So we're going to start with just crude measuring right at the DC in, but we'd like to be able to also measure per rail on the boards that'll let us do that.
We've got one board in the farm which has got 2 arm energy probes on it, so it's not just on the power DC in. And I think Lisa can probably talk about it more than I can, but we've had some problems with it, but we'll take that offline. But I'll talk to you about the specifics offline, okay?
Also, as to the performance of power testing, is it possible for normal user to subscribe some jobs for the performance of power testing? And if some regression happened, if it's easy, let normal user to do the git bisection for the regression.
Yeah, so the bisection, it's a Linaro job in Jenkins on ci.linaro.org, and if you need access to it, just send me an email and I can add you. I think I have you and Mark Brown have access to it already.
Yes, I once tried that, but it seems not easy to use at that time.
Yeah, there's you have to specify the Git tree. You have to supply a bad and good commit ID and the board that you want to use and the architecture. It's a parameterized job.
But he also wants to be able to bisect and then make a fix and submit that as well for another run through kernel CI.
Yeah, I mean, but that's what we do right now. I mean, he's got, I guess, the test branches on LSK that you could use, run the bisection, find the commit that did it, revert it, and put it in that test branch and check it. Oh, yeah, we're ways out for that. I don't think that's going to be there anytime soon. Yeah.
In a similar way, we have to have a way to say if you're checking for this type of regression, these are the few boards that I actually need to submit this job on.
Yeah.
We don't have that built in. We don't have an easy way to do that right now.
Yeah, and we don't have any way of bisecting tests at this point either. It's just boot, because it's easy to detect pass or fail, whereas tests might depend on test cases that are run before them. So just isolating the test case, it's a little tricky.
But I mean, Llvm can do this. We can say with device tags or whatever, say these are the boards that have feature X.
Yep.
And only submit to those.
Yeah, I think
we just don't have the kernel CI.
Exactly. Yeah.
So through kernel CI, I guess right now the API I'm using is called trigger build or something like that. Mm-hmm. Is there a way, if I have my own test, and let's say I run, I don't know, PCI, and I detect that it's failing, can I send back to kernel CI a message saying, hey, this kernel is failing, let's start a bisect and then give me the next point?
So we really like automatic bisection. I think that's where we want to go eventually, but it's not something that we've had the time to really dig into, because I mean that's pretty complex. I think we want to start with the boot stuff, because I think that's easier to do. When we basically using the diff view is what I we have to have an API call where we find a regression, we check that the last build of that same tree, and if it passed, then we know that there's an issue, right? And at that point, then we need to have like another external daemon that says, okay, I'm gonna take that data, I'm gonna run the bisection. And eventually, I think what we wanna do right now is the Jenkins job just kind of spits the git bisection log out at the bottom, but really what needs to happen there as well is send an email with the log in it, and also try a revert of that commit that it finds to see if it's actually the problem, because that's the next step that you have to do after you bisect it is, does that patch revert cleanly? And if it doesn't, can you fix it up by hand, apply it to a tree, and then retry your test? And so I'd like to have that all built into the bisection as well, so that essentially what you get back is a report saying, here's the bisection log, here's the outcome of reverting the patch, and did it boot? So it's basically like it's confirmed the issue that the thing that it's blaming is actually the culprit. So we didn't need to do that with booting first, and then we could probably add the testing after.
I guess the trick is if it is a test that Lava doesn't know how to run. Yeah. It's kind of, you have to tell the other system, okay, this is your new kernel. The other system run the test, then notify back kernel CI, hey, it passed or failed. And then until you finish the whole bisection.
Yeah.
I guess that's a different story. So for tests, you can store the results in kernel CI as well. So you can have the same mechanism for detecting, okay, it was working with this commit, it doesn't work with that commit, and then the bisection kicks in, and so you run it on your own farm. It doesn't have to be Lava. It can be something else. Yeah. Then, so
that would work. I mean, if I get a kernel and then I save the result saying fail, then Lava kernel CI send me, the next one.
yeah, that's what I'm planning to do. Exactly. So you can save. There is a schema. I'm not sure if Milo was talking about. There is a schema to save the test results in the kernel CI, so you can save them there and then query them back. So getting, okay, this was passing on this commit, it's not passing on this one. Right?
Who is triggering the build of the next bisection?
As soon as the tree changes.
Yeah, no, but I think what Carlos is getting at is, well, how are we driving the bisection, right? Yeah.
I want kernel CI to drive.
No, you probably have to do it yourself, right?
Yeah, I mean,
so that's what I'm doing. I'm querying the
it's outside of
querying for the build and then run tests.
That's why the job that I have that does the bisection is not actually part of kernel CI. It's just a Jenkins job that's standalone that takes those parameters in. But essentially, we could automate those parameters once we can detect that there's an event that's in a regression. And essentially, then we can query the API, have all that information, and then send it to that job. It'll perform the bisection using the same build scripts that we use to build the kernel CI stuff. So if you ever notice when you go look at kernel CI and you see jobs, there's bisection there. That's the tree name that we use for doing all the bisections. And so it actually pushes the results each time at each point as it works through the bisection, which is kind of nice because then you can go back at different points and use the build, and all the builds are published. So yeah, something like that would have to be done on your end to actually run through all of it.
If it's possible to make the bisection is automatic, like if there are some regression happened, whenever it's performance or power or even function failure, and git bisection should be automatically triggered and figure out what the commit is make the problem.
Yes, that would be that's an ideal world, and we'd love to get there.
Yeah, that would be very helpful. And actually, in the normal developing, some of the patches like try to improve the performance or power, but it's kind of, at least for me, it's very hard to do the testing in my hands, and especially without many boards to do the testing. So any code development without this kind of data support is hardly to catch some errors. So I hope it's kind of the performance or power testing it should be a very higher priority to help us.
Absolutely, yeah. So we can put that up on.
But then that's a sensitive data, so it's not something you would share.
What's that?
It's a sensitive data, isn't it?
Yeah, and I think that's why we're getting at this is something that individual developers need to use, and that it's not sent publicly, right?
But even if it's not power performance, even if it's just like I want to notice when I break Hackbench results or something, or when there's a regression in Hackbench results or something, or some delta. That we can do that. We're not doing even that right now, but it's just a subset of the examples that you're talking about.
It would be your case to publish like your increasing your Hackbench performance.
Yeah.
For example, like without saying any numbers, it's like it's worse than it used to be.
Yeah.
Then it will be safe to publish that publicly. With this commit, you
Yes, some of the absolute data is sensitive for the different windows, but at least the percentage change, you can say how percentage increase or decrease, and how much the time increase or decrease. Then it's okay. I think it should be okay for all windows. And in the industry, there are also lots of examples for this, so it should be okay.
I think that's a good idea. I mean, like a trend, basically, whether, compared to the last bill. I think where it gets tricky is if we start doing multiple trees. I guess it would have to be linked to the tree.
For tree and for board and for DTB and whatever.
I mean, then you have the matrix gets very large pretty quickly. But it's something that I think we need to go and do. So would the automatic bisection be a higher priority? I mean, at least with boots, or would be test visualization and getting the tests running be a higher priority in your guys' mind? What would be more helpful?
developer should all have all sense about BKK.
Yeah. Okay. That's good feedback. This is what we have these sessions, so we can kind of feel where we can help you guys the best.
So how do you handle compiler-related issues?
So another highest priority thing that we're supposed to do. So right now we build statically. We don't change compiler. We have the ability. I've got a job that I've kind of cloned and made some changes to where I can, throw compilers at it and have it build. It's something that the Llvm project that's kind of being talked about at Linaro is interesting because we'd like to add Llvm support along with GCC. And we actually had this discussion in a meeting a couple weeks ago before Connect was because each job then needs to be uniquely identified by the compiler, right? And so you might have mainline built 5, 6, 7 times with different compilers, and then the diff view that we have now would come in handy, right? Where you could actually diff, 5 different builds that all use different compilers and see the different build warnings and errors and things like that. So it is on our roadmap, and the toolchain team actually just asked us this week, formally for this support. It's going to take work on the build scripts and the build infrastructure to get it that far. And then it kind of comes down to, well, what tool chains do we use, right? People have been asking us for MIPS and PowerPC and M68K, and it's like, okay, point me at a tool chain that people use widely. And no one's, okay, I'll research it and get back to you, and they don't. So I think right now, we'll probably just use the Linaro GCC tool chains, unless there's a reason to go straight from GCC, just because it's, Linaro, and we might as well at least test the gear, and then we can help the toolchain team out here as well with that. So, but any other suggestions would be welcomed.
Well, my question was mostly related because I don't know if it's still the case, but a thumb2 kernel that's just a never-ending pain because then Binmutus breaks, then GCC breaks. So you get a lot of build failures and runtime failures just because your toolchain is broken.
Yeah. I think we also need to establish a policy of how far we go back with toolchain testing, because I think right now, at least ARM32, we're running 4.7, which catches some weird ICE errors every once in a while because it's a semi-old compiler. So I think we need to do personally is baseline the compiler. So we talked about this with Mark Brown, is that running 4.9 across everything right now, because right now we have 4.7 for the ARM32, then we're using 4.8 for ARM64, I think we're using 4.9 for x86. So at least establish a baseline and then, work up the versions from there, yeah. So maybe it is 4.9 that we stabilize on. It's pretty widely used now, so it should be a problem.
We're getting into kind of matrix multiplication problems here because we're been asked to vary compilers, but we're also being asked to vary U-boot versions and stuff like that. So that we're getting kind of explosion of possibilities here. So at some point, when we add these features, we're probably going to also say we're only going to vary compilers for, again, maybe mainline RC or something like that, or maybe just Linux Next or something, because hopefully that'll catch issues. And same with U-boot. We're probably not going to vary U-boot. Varying U-boot on most platforms is really difficult because we got to put it on MMC, and that's a pain. And so we probably might just do that on QEMU or a few platforms that maybe it's easier to change MMC. So. But we have some infrastructure problems to work out to add dimensions to the matrix here. So Amit, you had another question.
Thank you. One dumb question. Can I subscribe to build jobs, job reports? Specific job reports, not all the builds.
There's an item feed or an RSS feed you can use if you want to use that for a specific job and a specific tree.
Yes.
Actually, so for a specific job, actually, so you can get all the trees for a specific job. Yeah.
Yes, specific tree and all the test platforms.
Test. Yeah, we're gonna pull it up maybe.
Let's say there is a LSK Android job, and it's being validated across all the devices. So can I subscribe to at least the pass-fail results?
You're talking about build or boot?
Yeah, or both.
Both will work.
So the release tree, for instance, it's got the Atom feed there. So you could pull that RSS feed and only get details about this particular tree. Same with Linux Next, same with mainline, same with any other tree. So if there's a specific tree you're interested in, you could subscribe like that.
Yeah.
So you'd have to do a couple though, like you'd have to do LSK Android, 3.18 and then LSK Android 3.14. So you'd have to do a couple, but you can then get it filtered essentially by tree branch. You can get a feed per branch. We don't have it done in email form, but we have it done in RSS.
RSS form. That's fine. Thank you.
We should show them the diff view.
Yeah, sure. Okay, so since we have a little bit of extra time, we just show you the comparison view here. So, which one do we do a good job? You want to drive it? Yeah, sure, go ahead. Okay, so we'll just show you guys how to compare some results in kernel CI using the web interface and what that might, just do a, how about you do, yeah, go mainline, that's fine. Yeah. Yeah. No, I don't. Is it auto-completing? Just do a v4.3 or something, and then compare it to v4.4. Guess I've never. There it goes. Okay, so this is, we're comparing mainline v4.4 to v4.3. So this is just builds, right? So here, where we, maybe we added some configurations to 4.4. So what you see here is that, hey, we didn't actually build these configurations. Here, we might have, this one went away, right? So this def config doesn't exist anymore in 4.4 is what that's basically telling you. So this is kind of a matrix view. So what you see, if this is more interesting, is that maybe there's a build regression in 4.4 that's not in 4.3. And vice versa, you'll be able to see that. So the idea is we have it for builds, we have it for boots, eventually we'll have it for tests, and then we have an API that we can call to actually get this data, and that's how we would drive the bisection. Any questions on this? This is a kind of a beta feature, so if you guys would play around with it and solicit feedback, that would be great because I don't know how many users we have of this right now, but I think, 1, 2, 3. Yeah, 1, 2, 3. Yeah. You can probably just go ahead and search it.
So he reported a couple of issues already.
Remember the email thread?
Okay, just like getting the occasion here. So I moved this meeting that I had scheduled for today. I didn't move it yet, but I wanted to get to know if everyone's okay with Friday 12. So Mark is okay. Mark replied okay. Amit is okay. Kevin, you're okay? Friday 12.
Okay, you want to walk me through this one, Milo?
Yeah, so this is more or less the same as the job one you saw before. So you have a baseline at the top and all the comparison target here. So here you choose the tree, kernel, the dev config, and the architecture, and you can compare different builds, basically. So here, this is a comparison between next couple of weeks ago and all the multi v7 dev config plus the config fragments for the same date of the build. And here you have all the difference. This is old. All right. So yeah, this is a problem in Safari. So yeah, you get all the values here. The same here you have the same compiler. So that's the real version of the compilers we use. And then yeah, you have a matrix view of all the difference and the artifacts we track and all the things we track basically for a single build.
Yeah, as we work towards multiple compilers, I think this view becomes very interesting.
Yeah.
Because then we can start comparing def config builds across multiple compilers, GCC and Llvm included, and we can detect regressions. Obviously, you can see warnings and error numbers too, so you kind of have a sense of how many warnings and errors you're going to get between these two trees. Also, kernel image size, so we can track that across multiple builds as well. So this is starting to turn into a little bit of a big data project in the sense that we're collecting all this data, and it's really interesting if any of you guys are into like MapReduce or any of the big number crunching cloud services to help us out analyze this data, because we could probably find some really interesting trends with all of it. But currently right now that's not really our focus. Our focus is trying to keep Linux booting on all the platforms that it should. But I think there's probably some more that can be extracted out of this data. Any questions? The quiet group.
Do we have the API right now for people to go and query the same if they want to write their own tool to analyze kernel image size trends?
Well, not for this one. So there is an API, so you have to have all the values and just send the data, and you will get a JSON response, but basically is a concatenation of all these devconfigs builds. So there's no math, there's no difference in the API, so you have to do it by yourself. Otherwise, you have to extract all the data and do the trending by yourself. So.
And just to note, you want to take the API page just so they can see. So if you guys are ever curious about what our APIs, our services offer, if you go to api.kernelci.org, there's some documentation, there's worked examples, there's the schemas, the JSON schemas that we use. So you can see, like the test schema, for example, or So yeah, we kind of try to break the way we organize the test down, and the idea here is we want to make kernel CI, so the front end that you're seeing right now, well, this is the API front end, but the back end is just this big warehouse where we try to develop schemas that are generic enough that anybody could use the back end to store data and then build a different front end that exposes that data in a different way. So if you want to take kernel CI back end in-house and build a different front end for it, for whatever product that you're building, maybe you have different requirements than us, that's kind of how we've designed it, so that it's the front end and back end are completely separated, and you can use the data to store it in the back end and then put whatever front end you want on there. So the way we kind of broke this down was there's a test suite, like LTP. There is a test set, so there might be like the math library in LTP is a test set, and then there's test cases under that math library. So we tried to make this as generic as possible so you could essentially describe any kind of test. Now you can say, I just want to submit just a test case, and you can push that. Or you want to describe a test set, which is like the math library of LTP with multiple test cases nested beneath it. Or you can describe the entire test suite, which is LTP and all the different test sets with all the different test cases. So it allows you to either just push one test case or the whole thing back to the back end. And so we try to make this as general as possible. So if you guys would review some of this documentation, if you see something that's missing, just shoot us an email saying, hey, I don't quite think this fits, or here's my use case, and this doesn't really work. And we can help modify it.
How about access control there? So that's something we were discussing now.
Yeah. So as far as who gets a token for the API?
No, not exactly. So how about about you can query with a token, right? But you shouldn't be able to query everything, for example.
It's private data.
Private data.
So we don't have that. Yeah. We discussed it, but we don't have it now. We have to work on it.
I don't know. By definition, kernel CI is supposed to be open data.
Yeah.
Exactly. But that was why we never actually thought about it.
I mean, do we really need to do
implementing it or thinking about it.
Yeah, if you store your performance data there, then yes.
Well, whatever you push is.
The problem with the performance data, from my point of view, is that as long as you have the data, and in some way we control what we show on kernel CI, we don't do comparisons. So as long as the data is public, you can still do graphs from the same kernel, for the same tree, for the same board, without comparing to the others. So
No, it's like if you have a token to query that, then you can dig all the data right yourself.
yeah, that's the other problem, exactly.
Yeah, that's the problem I'm trying to solve, not the problem that you store the data and it's there.
That's one of the problems we didn't want to solve with kernel CI, actually, because we wanted this to be public, since everything should have been public. So yeah, it's a compromise.
Yeah, I think it's a slippery slope.
Yeah.
I think in those cases, it's almost better to have a different backend where you store private
Yeah,
data.
exactly.
Right? The public instance should be everything's open, right? It's just for the community's benefit. To show people the status of the Linux kernel on various platforms.
Yeah.
So yeah,
So
I mean,
then, okay.
but we have this dual use case, right? Where at Linaro we need to do performance measurements and try to reuse common infrastructure. I think
Yeah, but
that's where
so then we can have a separate instance. How do we sync between the instances, for example?
I think the private data stays in one and the public data stays in the other.
No, I mean like the private data. I push only the test measurements to the private instance, right? But I don't want to copy over all the boot and test reports
That's
there.
that's a visualization problem. But as long as you don't
No,
need the
it's the
data,
access problem.
in which sense?
So you can have a separate, you can have a token to query the stuff, right?
Yeah.
And then if you say it's your
Oh, okay, yeah,
visualization
still
problem,
anyway.
then like this user has access to this data, how do I tell?
Oh, no, wait. So I think there's two different things. So if you want to use the public builds and then run tests, but has to be private, you have your own kernel CI instance where you store only your test, and that's, you deal with the access problem there, and you deal it or at the front-end level.
How do you connect like the presentation of the, like, so you have two databases basically, right? So how do you connect them together so not to duplicate the data?
So but it depends if you need the data on your side locally, like on the database, or if you don't need the data. So if you just need for visualization purposes, you link it back. It's just like where is the data stored? It's on the visualization part, something will be linked on kernel CI, and all the other private part will be locally to your instance or whatever.
And we can talk about
Yeah,
that.
maybe that's a discussion for Brian,
Yeah,
because I think we have a different, we have an interesting use case because we're trying to use it for these private use cases, but keep it public at the same time.
Yeah.
And I think we need to figure out the solution there, yeah. Let's talk more on Friday.
For spreading the word, have you considered writing an article for LWN right after kernel release? Making summary, some graphs or something like that?
Yeah, we could definitely do that. We haven't really tried to hype this up too much, just because, well, what ends up happening is people say, we want all this stuff, and it's like, well, Milo and, the sliver of time I get to work on this now is, kind of all we have. So with the hype becomes pressure to deliver, and, we don't really, this is a Skunkworks project, right? So this is just because we wanted to see this happen. We've kind of made it happen. So, I think that it makes sense to do, but I do fear some of the backlash of, that's great, but here's all the stuff we want, and being able to deliver that in a timely manner, I think is a concern. So we're on the mic to Rico.
One thing I wonder is that the kernel boot logs themselves are not necessarily very coherent. They have some kernel modules that are really noisy and announce a lot of stuff, and they don't mean anything, and other modules don't necessarily say anything when they load. So for just watching the boot log, you don't actually know if everything is there booted properly.
Good point.
Is there any plan, like in the upstream kernel, to make it more standard how the kernel device drivers initialize and announce themselves?
I think the answer to that question is no. The kernel developers are not really fond of standards for these types of things. But where the effort should be placed is essentially the next level, which is kernel boot logs can be arbitrary, and they can even be disabled, right? You can boot with add quiet to the command line, and all of it goes away. The important thing, I think, would be the next step would be to have a k-self test that actually tests the kernel feature that you want, that's slightly more reasonable, that would actually load the module that you care about, and then actually poke at it to see if it's doing what it wants. I think that's the direction, is actually having not necessarily doing functional tests based on kernel messages, but actually having a real test to do it. We're relying on boot logs right now to be a pretty crude way of detecting a few things, but it's not that doesn't really scale.
And standards was probably a bad word. Let's say best practice.
Yeah, test best practices. Yeah, but that's another thing that's hard to get. It's hard to get kernel developers to agree. Period, and it's especially on stuff like that when it comes to kind of print K messages standardized across modules would be hard to do, I think.
Could init call debug help here?
Can you call debug?
If you put that in your command line, then you see all the init calls. It's noisy, but it's really, really helpful.
It's noisy, and it could also you could also detect patterns there when certain features or drivers aren't actually loading.
Yeah, it's what Bootchart is using.
Yeah, but this is actually that reminds me. The whole module thing reminds me. This is another area where we've caught quite a few bugs because a lot of kernel developers build a kernel and boot it and load the one module they care about or no modules. So what we do now, actually, our RAM disk actually will basically any module that probes, it'll do the UDEV and load the module bit. So we're actually for kernel builds that build a lot of modules, it's actually loading a bunch of modules, and a lot of times we found a handful of bugs that way. And the kernel developers say, well, I don't have that problem. And some stuff, especially with deferred probe and stuff like that, they don't have the problem because they only loaded one module. Or they manually have a script that manually loads the modules in the right order, but when they actually probe, they get probed in different orders and stuff. So that kind of stuff, we actually test all that module auto-loading stuff we catch, and so things have stabilized, I think, there, but we caught a handful of issues around the modules.
Well, I think we made enough noise that people understand that we're testing that now, and so before they're submitting patches, they're just doing a quick test check now. So it's good. We're having some influence, I think. Anything else? How are we doing on time? Yeah.
One other thing on the or the kind of advertising thing. So we've done talks like this at ELC a couple times. This last kernel summit, I was there, and I also did a presentation at Kernel Summit about some of the features we're working on and what we're doing with it and so on. So at least among the ARM kernel community, there's been a lot of people that have been aware of this for a while because that was kind of our initial target audience. But now the broader kernel community is aware of this as well, and kind of we're doing more of publishing results on all the stable kernels. We're sending build emails to the Linux Next every time there's a Linux Next, and so we're kind of becoming a bit more broadly aware in the kernel community too, and we're getting more people looking at the website and asking us for certain features. But like Tyler said, usually every time we do a talk and advertise, it just adds a bunch more things that it reminds us of all the stuff we already have to do and then adds 10 more things that we should do. So that's why we're kind of, part of the thing here is begging for help as well.
And to kind of add onto that, we're doing the stable queue. So when Greg Cage sends out the stable queue email, Gunther actually has a Git tree, because Greg has it all in Quilt, right? So Gunther, bless his heart, puts it all in Git for us, and then we suck it down, and we actually do build and boot tests, and we have a daemon that Milo wrote, which will actually detect when Greg sends that email out. Once we have the boot results, the bot completely replies to that thread and adds the results to kind of everybody else that's doing the testing. So that's been helpful in some of the LSK testing, because the idea is, if there's regressions that are coming through stable that are going to make it into the LSK, we catch it before it ever hits stable, and then it never makes it in the LSK, and that's kind of been the thought there. So work upstream to help our downstream.
Yeah, and Greg now waits for these emails before he'll get all his stuff ready and publish this review request, and he'll wait for people to reply to that before he decides to bless the stable. So if kernel CI responds and says it found a bunch of new boot failures, he'll actually check with us and say, are these really things that we worry about? And we can say, no, we know about that one. It's actually not a real bug or whatever. So it's actually become part of the stable release process actually involves these boot testing now. So
we have a few minutes left. Anybody else have last minute question? All right, thanks for your time. We appreciate it. Thanks for all the support, guys.